can travel faster than light. But is that actually true? In some senses, in most senses even, it is. But also, it's an idea, a statement, that has an asterisk next to it. To some degree, light isn't always the fastest thing in the universe. But let's scale back. The speed of light was measured for the first time all the way back in 1676, when the Danish astronomer Ole Romer applied it to how long the eclipse of Jupiter's moon Io took to pass. Before then, most scientists had assumed that light speed was probably infinite. Ole Romer's original calculation, while a good first attempt, turned out to be slightly off. But after a few revisions over the years, we today know that light travels roughly at 186,000 miles per second, or 300,000 kilometers per second. However, that's only true for how fast it travels in a vacuum. The speed shifts when it travels through other mediums, while light can also scatter through a prism. The occasional separation of light as a rainbow on Earth is one representation of this. The strange thing about darkness is that it's not so easy to track, measure, or even really to contemplate. Since it's merely the absence of light, common sense might say that these two fundamental opposites, light and dark, should travel at the same speed. But that's not always the case. In certain circumstances, darkness can sometimes outspeed light. The simplest, most well-known, and most universal example of this is shadows. In almost all discussions of dark, shadows are used as our window into how it really works. From the New York Times to Vsauce. The thing is that shadows projected onto a distant enough surface can seemingly, theoretically, beat the cosmic speed of light. Cast a shadow, move it around, and it's possible for that patch of dark to travel much faster than the light that's surrounding it. Or at least it appears that way. Darkness is something that's able to travel faster than light while actually not breaking any physical laws. There are other things that can do this too, such as the expansion of the universe. Expansion shows that every galaxy or galaxy cluster is growing farther and farther away from each other at very high speeds. And the most distant galaxies are actually retreating at speeds faster than light. But the universe isn't breaking any rules here, since it's the actual fabric of the universe itself that's expanding. The fabric of the universe doesn't technically exist within the universe, and so it needn't obey all the same laws. Another something that seemingly breaks the speed of light is quantum particles. Studies have shown that quantum particles can interact with each other at faster than light speed. However, scientists are so far yet to identify a way to convey any information through them. And here's where one of the specificities for light is key. It's the fastest thing that does convey information, or that does essentially communicate with whatever it's traveling through. But back to darkness, and you might justifiably argue that darkness communicates too. But the subtleties at play can be demonstrated with a shadow puppet thought experiment. Imagine you're putting on a shadow puppet performance for the entire solar system. And so you rig up a massive, millions of miles wide screen somewhere in the void between planets and shine onto it a light that's even greater and more powerful than the sun's. Position yourself correctly between the light source and the screen, and you'll be able to move your puppets from one side of that screen to the other, a journey of, again, millions of miles with just the flick of your wrist. One moment, the darkness you're projecting is on one side of your colossal canvas, and the next, it's on the other. Not even light can move as quickly as you've just seemingly moved dark. But here's the rub. The light you've used to cast your shadow will have still taken the speed of light to reach the screen. From there, yes, you'll have zapped dark across your target much, much faster. But the darkness is, in a sense, what light creates it. Without the speed of light that's not the shadow, the dark within the shadow doesn't move at all because it doesn't exist. Similarly, if the sun, for some reason, were to stop shining, it would take just a little more than 8 minutes for Earth to actually fall into darkness. We're not dealing with shadows anymore, but a total absence of light. Although the same basic rules apply. A little more than 8 minutes is how long it takes for light particles from the sun to reach us. So it's also how long it would take for the final rays of light and then dark to reach Earth too. The impending darkness wouldn't and could never speed up that time though. Because of this, the problem is broadly divided into two. Depending on who you ask, Some scientists will say that darkness travels at the exact same speed as light does, while others will disagree, mostly because it's probably not a question that actually makes sense to ask. Some argue that darkness doesn't have any speed at all, because darkness isn't actually real. Light is real, and light waves are an actual observable phenomenon, but darkness is simply the absence of light. It is without light, but it can't exist without light either. Asking how fast dark can travel, therefore, isn't logical. The astrophysicist Neil deGrasse Tyson has compared it to asking what kind of cheese the moon is made out of. Grammatically, yes, it's a question, but logically, it isn't one that has a serious answer. deGrasse Tyson further clarifies by saying, quote, "If dark is the absence of light, then dark has no speed at all," end quote. In some senses, then, you might also say that dark has a speed of 0. It's a tricky concept to come to terms with, but the reason that dark can appear to travel faster than light is because nothing can outspeed light, and dark is, literally, nothing. What really matters regarding the cosmic speed limit is that ability to communicate something to pass information at that speed. Even if you were to expand your shadow puppet empire then, so that you put on a show on a screen spanning across the entire universe, it still wouldn't matter. You still wouldn't be conveying any actual new information with your shadows, besides the absence of light, the conditions for which will have taken light speed to happen. Ultimately, the speed of darkness really comes down to how the darkness is defined. In this video, we've mostly focused on the absence of light in shadows, but we could also expand the definition to include other cosmic phenomena that do have different speeds. Enter dark matter and dark energy. Really, dark matter and dark energy are called dark matter and dark energy because scientists have so far been unable to shine light, of the non-literal kind, on what these mysterious concepts could be. But still, some researchers have tried to measure dark matter's speed, with one 2013 study theorizing that dark matter moves at 54 meters or 177 feet per second. Similarly, black holes offer another alternative. We know that black holes' gravity is so strong that even light fails to escape the darkness. So could the darkness here be thought of as quicker? In one sense, yes, but in most senses, no. Again, there aren't any physical laws being broken up until at least the event horizon of a black hole, after which many laws do break down. But until then, the dark isn't outpacing the light. Nevertheless, there are some ideas for faster-than-light travel relying on wormholes built from black holes and corresponding white holes, so science seemingly does foresee more links in the future. For now, depending on your definition, asking how fast dark is could be seen as similar to asking what came before the Big Bang. Both sound like legitimate questions, but don't have actual answers, depending on your take on the science. Still, if you simply view dark as the absence of light, and as technically nothing, and if you understand that nothing is faster than light, then that's what